Hello, welcome to section 5.3, which deals with multiplying polynomials. We're going to take the stuff that we've learned about exponents up to this point, and we're going to use it. So I think we've already done some of these multiplying monomials. Okay, so if you have monomials, remember commutative property lets you multiply the constant parts times the variable, combining the exponents, right, in the variable. So that's 2 plus 3, which is 5. Okay, remember when you same base multiply, we add the exponents. So here, for B, we're basically doing, multiplying 5, 6 times 12. Then X, we have 3 and 1, so 3 plus 1, which is 4. And then Y to the power 1 plus 2. Okay, so this goes into, 6 goes into 12 twice. You get 10, X to the power 4, Y cubed. Okay, now if you're multiplying a polynomial by a monomial, you're basically just applying the distributive property, okay? So, and then you just multiply each term by term. So you have negative 2y times 4y squared, that becomes negative 8y cubed. Negative 2 times 3, so negative 6y squared. Then finally plus 10y. Okay, so I'm gonna... So what did we do? We just took negative 2y multiplied by each term. So here, we're going to multiply each term by 3x squared cubed y. So if you want to see it written out, hopefully we have enough. Okay, so times x squared. Then what we did was we went minus 3x cubed y times 8xy. And then plus 3x cubed y times y squared. So that's essentially what we're doing, right? When we distribute something, we use distributive property. We multiply by each term. Okay, so let's go ahead and do that. So this gives me 3x to the 5th y. This will give me here 3 times 8 is 24. X cubed times x to the power 1, that's just 4x, x to the power 4. And y times y is, of course, y squared. Then the last term, it's 3. Then we have x cubed and then y cubed. That's it. Not too bad. Okay, so now we're getting into multiplying polynomials. So this, to multiply binomial, there's many different ways to do this, but I will teach FOIL method just once, probably because other people have done it, and some of you are very familiar with this method and would like to see it again, and it might be easier for you to multiply binomials using this method, which is totally fine. And also, if you practice this method quite a bit, it does help with a certain type of factoring, which we will get into in the future. So those are all the reasons. Okay, so when you multiply two binomials, basically you're like distributing, okay? You're distributing a binomial twice, but then you distribute that term into that binomial, so it becomes like this crazy thing. So we came up with this acronym. I actually don't even know who first came up with it, but it's called FOIL. So one way is you would take the first two terms, so that's your FOIL, that's F part first, then the outer two, so that's your O, then the inner two, so that's your I, and then your last two, so that's L. So at first, outer, inner, last. Okay, so let's practice this. And then that's the product of the two binomials. So, okay, fine. So first, so y squared. Then outer, that's 8y, so plus 8y. Then inner, so that's plus 5y. And then last, so that's plus 40. Let me do this. This is the O, and then this is 40. Okay, so again, so what did we do? We did first, outer, the product of the inner terms, and the product of the last two terms, okay? Now we just combine them, and we get y squared plus 13y plus 40. Okay, so let's do the next one. So first, 8y squared, outer, negative 20y, inner, 6y, positive, and then last, negative 15. So then that becomes like terms, 8y squared minus 14y minus 15, okay? Now, I'm even more excited. Just kidding, it's still exciting. I want to teach you guys a different method to multiply. Some people find this method a lot easier. And the thing I like about learning this method is that it doesn't just have to, it's not just restricted to binomial times binomial. You can multiply any polynomial by any polynomial using this method, which is called the box method. And you'll see why in a second. So, okay, great. So to do the box method, first of all, you count the number of terms in your first, so this is a 2 terms. And then we count the number of terms in the second factor. So you're going to draw a box that's 2 by 2. So that's the first thing. Then you take one of the factors and you just write each term occupies its own little box. So y has its own little box, -7 has its own little box, and on the top y, and then +4, or you can think of it as y plus 4. And now that you've set up your box 2 by 2, each term belongs to a box. We're going to just take the product, like if it was a multiplication table. So y times y is y squared. Okay, and then you would have 4 times y, and that would be 4y. Then you have y times -7, which is -7y. And then 4 times -7 is -28. Okay, so then we would just combine like terms, and the like terms, if it's usually diagonally, but not, in this case, when you're doing a binomial times a binomial that have similar variables, yes. And then you would just write down your answer. So y squared, and then -7 plus 4 is -3y minus 28. And that's it. So, it took a little longer maybe to explain, but, well, I actually don't know. But I feel like this is a lot easier. It helps you see your stuff. And then especially when you get to larger polynomials, it's easier to combine like terms because then you can cross out the boxes or what have you. So let's do another one here. So this is a 2 by 2. Okay, and then on one side we write 4x plus 3, or 4x and 3. This one is going to be 2x, and then minus 5. Okay, so 2x times 4x is 8x squared. 2x times 3 is 6x positive. 4x times -5 is -20x, and then 3 times -5 is -15. Like terms, we get x squared minus 14x minus 15. And that's it. Okay, let's try another one. Okay, so this is a 2 by 2, 2 terms by 2 terms. This is also 2 by 2. Okay, so for A, you have n squared plus 4, so n squared plus 4. And then the other one is n minus 1, or n plus the -1. Okay, and then just fill in the boxes. So n squared times n is n cubed. 4 times n is 4n. -1 times n squared is just -n squared. And then 4 times -1 is -4. So it does not look like there are any like terms here. So n cubed minus n squared plus 4n minus 4. And that's it. So then let's do the next one. It's a 2 by 2er. 3pq plus 5, and then 6pq minus 11. So multiplying inside, 6 times 3 is 18. We get p squared q squared. 5 times 6pq is 30pq. 3pq times -11 is -33pq. And then 5 times -11 is -55. Like terms right here. So it's just 18p squared q squared. 30 minus 33 is -3pq, and then minus 55. All right. Now, the nice thing about the box method, so check it. This is a situation where you could not use FOIL. you know? So what do? You just have to distribute, and it gets into this big crazy mess. But now that we have the box method, we could go, okay, this is going to be a 2x3 box. So I'm going to do 2, and then I'm going to have 3 boxes. Okay, on the side I have my binomial b plus 3, and then on the top, 2b squared minus 5b plus 8. Okay, so let's go ahead and fill it in. We get 2b cubed here. B times negative 5b is negative 5b squared. 8 times b is 8b. 2b squared times 3 is 6b squared. 3 times negative 5b is negative 15b. 8 times 3 is 24. So like terms, let's find them. And then they are diagonal. So 2b cubed, so that's that one. 6b squared minus 5b squared, so that's a positive b squared. 1b squared, right? Negative 15b plus positive 8b, so that's just the difference between 15 and 8, and it's 7, but it's negative. B, right? And then just 24. So that's positive 24. And that's it. See, it's a lot nicer. Okay, so next thing we want to talk about is patterns, right? So binomial squares have a certain pattern, okay? And that's something that we're going to look at more in depth. But just to begin introducing, the pattern is the first term squared plus twice the product of the terms plus b squared, which is the last term. So you square the first term, square the last term, and then double the product of the two numbers. Okay, so here's an example. You have x plus 9 parentheses squared. What does that mean? X plus 9, x plus 9. If you did Boxer or you did FOIL, you would see that it's square the first term, square the last term, and then 2 times the middle. So square the first term, square the last term. So this is the first term, this is the last term, okay? Plus, and then twice the product in the middle. So that's going to be 2 times 9x in the middle. So that's just going to be x squared plus 18x plus 81. So you could see it saves a little bit of time, right? It saves some steps. So instead of doing here, instead of going through, okay, what does square mean? That means I write it twice, and then I do a box, and then I do FOIL, and then I go over here. You could just go, wait a second, this is a binomial squared, so square the first term, square the last term, which is plus 7 squared, 49, right? Because negative 7 times itself becomes a positive 49. Then twice, so then whatever sign this is, I continue, and then twice the product. So 7y times 2 is 14y. Okay, and that's it. Let's try this again. So square the first term, 2x times itself. Square the last term, 3 times itself. And then twice the product, so 2x times 3. And it's plus. So then final 4x squared plus 12x plus 9. So if you practice this quite a bit, it'll get a little easier and easier. So here, okay, so x plus 5, quantity squared. Square the first term, square the last term, okay, and then twice the middle. So 2 times 5x, which is 10x, okay. All right, let's try this one again. Let me write it out. So 2x, square the first term, square the last term, and then add twice the product of the two. Or just basically, you can think of it this way. If this is a negative, this is going to end up being a negative. 2x and then 3y, okay. So then this is a plus. So then we have here 4x squared. And then 4, 3, that's negative 12xy. And then the last one is plus 9y squared. And that's it. Okay, we will have a part 2 to this video, so be right back.